Good day, I am Jed Irene Mendoza, and I will be your robotics teacher for today. Last meeting, we discussed about basic Arduino circuits, and for today, we'll have a new topic about a new sensor. With that, are you familiar with this game? Yes, this is Just Dance. How do you play Just Dance? Very good. You follow the dance steps that is being shown on the screen. Is that correct? So when playing Just Dance, how does it work? Or how do you start playing? Yes, before you can choose a song to dance, you need to stand in front of the console, in front of the camera to do several movements. And why do you think you need to do several movements before you can even start the game? Yes, very good, because Just Dance machine uses a motion sensor that detects your movement. That's why before you can even start the game, you need to stand in front of the console and at least wave your hand just like this, right? So that the machine can detect you. A lot of machines, actually not just the Just Dance game console, uses a motion sensor, which is called the PIR sensor, which will be our lesson for today. For the lesson objectives, we have number one, explain how PIR sensor works. Number two, state different uses of a PIR sensor. And number three, design and program a PIR sensor circuit using Autodesk Tinkercad. Remember that Autodesk Tinkercad is a platform, online platform that we are going to use to create a circuit virtually, since we are having virtual classes right now. Now to start, first question, what is a PIR sensor? Anybody? Thank you. So according to this, passive infrared sensor or PIR sensor allows to detect motion of people, animals, and cars to trigger different types of response. So basically, this detects the motion of things that emit heats, just like people, just like us, which we emits body heat, right? So this is for the PIR sensor to trigger different responses, like for example, turning on the lights, producing very loud noise, and etc. Now, this is what the PIR sensor looks like in real life. All right. And then aside from the Just Dance game console that we mentioned a while ago, we can also encounter PIR sensor in public bathrooms, which has the automatic light sensors. Wherein when you walk inside the bathroom, the light will be automatically turned on. With this, the PIR checks if there is a movement around, and if movement is detected, it will automatically turn on the light. So while you are in the restroom, the light is still turned on because the PIR sensor detects your movement. That is if you're moving. But if you're just standing still, the PIR sensor will not detect you and it will turn off the light because again, PIR sensor is a motion sensor. It detects motion, right? So another important example of where PIR sensor is used is the security alarms. Well, this allows the households to detect unusual movements in the area. And when unusual movement is detected, it will turn on the alarm, which is mainly composed of a red light and a very loud noise, a speaker, so that the neighborhood will be informed that there is an unusual movement around the area, and with this, crimes will be prevented. All right? So far, any question? If you don't have any more questions, I think we can start with the PIR sensor connection. So this is how we connect the PIR sensor in our circuit. So later on in our circuit, we will rotate this. So this pin right here, that will be on the most right, will be connected to the ground, which has negative charge. The middle pin right here must be connected to the power pin, which has positive charge. And then the pin on the left side, or the last pin right here, must be connected to the digital pin. We will use the digital pin for programming later on. Then this is the code structure of how we are going to program the PIR sensor together with the other components. So we have here the variable PIR, and then we set this to the digital pin where we're going to connect it. And then we also need to have if-else condition for the circuit to know what to do if there is a movement detected and what to do if there is no movement detected. So let's go to Tinkercad. So I have here my breadboard already connected to Arduino Uno R3. So remember, for this, you have to connect the negative part of the breadboard, of course, to the ground, which produces negative charge, and then positive part of the breadboard to the 5 volts, which produces positive charge. Now, for this, I have here the PIR sensor. Remember, when we hover our mouse to the pins, you will know where you need to connect them. All right, so for this ground, it means it needs to be connected to the negative. So I'll connect it here, which is the negative part of the breadboard. And then power must be connected to the positive. And then for the signal, we have to connect it to any of the digital pins. You can choose any number. Just remember what number you're going to use because we are going to utilize the digital pins later on in the programming part. So for the signal, I'll just connect this to digital pin number 1. After connecting, don't forget to change the color of the wires for you not to be confused and for you to know what charges are flowing for each connection. For black, it's negative. For red, it's positive. So this is how we connect our PIR sensor. And then for the coding, we will just use, again, the structure that I discussed earlier. So we have here set PIR to the read digital pin. And then we will choose pin number 1 because this is where we connected our PIR sensor. Pin number 1 right here. And then next, we will have the conditions. If the PIR sensor is equal to high, it means if PIR sensor detects a movement, then what will happen? And if no movement is detected, then again, what will happen? So we're done with the coding structure and how we connect the PIR sensor to our Arduino circuit. Now, if you don't have any more questions, we will discuss a very simple circuit, which is the security alarm. Again, for the security alarm, you need to use the following components. Of course, the PIR sensor, light bulb, resistor, piezo, breadboard, and then Arduino Uno R3. We discussed these components last week, so I hope you can still remember them. For this circuit, we have to program with this condition. The light bulb must light up and the piezo must produce a sound when movement is detected. Remember, if there is unusual movement around the area, the piezo or the speaker must produce a very loud noise and the light bulb must be turned on. All right, so let's go back to the circuit. So we will add here a light bulb and then, of course, the piezo and the resistor. So for the resistor, we need to connect it to the piezo. So this is how we're going to connect each of the components. For the light bulb, we have 2 terminals, the right side and the left side. So for the right side, it needs to be connected to the negative. And then for the right side, it needs to be connected to the positive. Alright, so I need to have another wire right here. And then the positive, I'll just connect it to pin number 2. Just like that. So for this, I connected the light bulb to digital pin number 2. And then for the piezo, positive and negative connections are indicated. So this one is negative. I'll connect this here. Change this to black for the negative connection. And then the positive leg is connected to the resistor, so I'll just connect the resistor to another digital pin, let's say digital pin number 3 right here. And then of course, I'll change the color to red. That indicates a positive connection. So this is how we connect all of our components together. So we have here the Arduino Uno R3 breadboard, a PIR sensor, light bulb resistor, and a piezo. Now, for the coding, we have here if PIR is equal to high, it means if the PIR detects a movement, then what will happen? Right? So if PIR is equal to high, then we must turn on the light bulb. To turn on the light bulb, we need to use set pin block and then to high. And then we need to select pin number where the light bulb is connected. In our case, we connected our light bulb to pin number 2. So I selected pin number 2 to high. And then when a movement is detected, of course, we need to play picker. We will use pin number 3 with this. All right. Now, if there is no movement detected, then what will happen? So we will have set pin number 2. We will set the light bulb to low. It means turn off. And then we will also turn off the speaker pin number 3. So let me just discuss this code very quickly. What will happen here is if the PIR sensor is equal to high, it means it detected an unusual movement. We will have set pin 2, which is the light bulb to high. We will turn on the light bulb as well as we will play sound on speaker pin number 3. Pin number 3 is where we connected our piezo right here. Now, if there is no movement detected, the code will proceed here. Set pin number 2 to low, meaning we will turn off the light bulb as well as we will turn off pin number 3, which is the piezo or speaker. Alright, so that's it. And then to start and to test if our code works, we will start the simulation. So for this, let's say this is a person standing still in front of a PIR sensor. As you can see, there is no output, there's no light, there's no sound because the person right here is just standing. It's not moving, right? So what we need to do is to click this, hold this circle right here, and then move this a little bit. Let's see what will happen. All right, so that's it. I moved this circle a little bit. So what happened is the light bulb turned on, and as you heard it, the piezo also produced a very loud noise. The purpose of having a very loud noise is because this is a security alarm. This is for the neighborhood to be informed that there is unusual movement around the area. Right? So with this, our code is working correctly as well as our circuit. So do you have any questions? All right, if you don't have any more questions, I have a question. What's the importance of using a PIR sensor in today's technology? Very good. How do you think Tesla's self-driving car works? Right? It uses a bunch of sensors to safely run on the road because that is a car. It is very prone to accidents. And one of these sensors is, of course, the PIR sensor. Since PIR sensor can detect movements of most things, animals, humans, it allows the self-driving cars to avoid accidents. Now, for your activity, I want you to look into more technology that uses PIR sensors. I want you to select one, then create a program and design a Tinkercad circuit. This activity is worth 20 points, and this is how you will be graded. 10 points for your creativity, 5 points for your circuit design, 5 points for your coding. And then for the submission, you have to upload your Tinkercad link on the submission form. Due date will be on or before the end of the asynchronous period. Do you have any questions or clarifications about our lesson? All right, if none, thank you very much for listening and participating. Again, I am Jed Irene A. Mendoza, your robotics teacher for today. Bye!